The most important part of soldering is the setup. Quality soldering is only possible if everything is arranged for you to succeed. You will only be holding the soldering iron in one hand and the solder itself in the other. You will not be holding the components to be soldered, nor will the components be sitting directly on the table or resting loosely on a stand. They must be secured. In the makerspace, we have a number of options for you to secure your workpieces. The first is called Helping Hands. The second is the Omnivice. You can check both of these things out from the tool crib. The last option is the adjustable circuit board holder. One of these is located at every soldering station in the makerspace. The next most important thing is that the joint you are soldering should have a mechanical connection whenever possible. Before even applying solder, you should be able to flip your piece upside down, rotate it, etc. without the joint coming undone. This will create a stronger bond in the end and will make it easier for you to achieve a properly soldered joint. For through-hole components, you can bend the legs on the back side of the board to make sure they are secure. If you're soldering a component that can't bend to make a mechanical connection, like headers, maneuver your workpiece so that you can apply a little bit of solder to one end. Once cooled, flip it over and continue as normal. One other very important aspect is polarity. If you have a polar component, like an LED, make sure you orient it properly. LEDs, for example, usually have a flat edge and a long and short leg. Other components may have a white line or flat face. Use the datasheet to figure out which way it should go in your circuit. Now, let's get to soldering. The first step of the process is tinning the tip of the soldering iron. Tinning is just the process of melting a little bit of solder onto the tip of the iron. It should appear bright and shiny. This will help heat flow from the iron to the joint. If you notice the shininess of the tip begins to fade, insert it firmly into the brass wool and twist a few times until it's clean. Then retin the tip. The proper technique for through-hole components is to first heat the joint. Make sure the iron is touching both the leg of the component and the pad. After a few seconds, introduce the solder and let it flow over the joint. Remove the solder and continue heating for 1 to 2 seconds. Lastly, remove the soldering iron. A quality joint should look like a Hershey's Kiss. If you remove the iron before the solder, it will get stuck in the joint. If you ever need to be reminded of the steps while soldering, refer to this guide by Adafruit. When you're done, clean up the ends with a wire cutter. What not to do when soldering. Number 1. Do not melt the solder onto the tip of the iron and then wipe it onto the joint. Number 2. Do not use too much solder. You will risk shorting your circuit. Number 3. Do not use too little solder. You will risk not making the connection. Number 4, do not apply too much heat to the joint. Number 5, make sure the solder is actually connecting the components to be joined. And number 6, this is what's called a cold joint. The components being soldered were not heated sufficiently, so the solder did not flow nicely over the joint. Instead, you see a bulge just above the joint. There are 3 primary desoldering methods. The first is solder wick or solder braid. It is most useful for removing solder from surface mount joints. Place the wick on top of the solder to be removed, and then place the soldering iron on top of the wick. Once melted, it should flow onto the braid. The second is a manual solder sucker or desoldering pump. Press the pump down until it locks. Hold the solder sucker in one hand and heat the joint to be desoldered with the soldering iron in the other hand. Once melted, place the tip of the solder sucker near the joint and press the button. The solder will be forced into the pump. The third is a vacuum pump. Turn the pump on. Place the tip over the joint to be desoldered, press the button on the pump handle, and let it do the work for you. Other soldering applications include surface mount components, wire-to-wire connections, and wire-to-lead connections. For wire-to-wire connections, you have a few options, but before you solder, make sure you have enough of the wire itself exposed to work with. The first way to make a mechanical connection is to wrap one wire around the other. Another option is to push the ends of the wires together and use the friction of the frays to hold them together. Additionally, you can use what are called solder sleeves. Slide the sleeve over one wire and then insert the other wire into the sleeve. Use a heat gun to form the connection. This also waterproofs the joint. Lastly, you can use heat shrink tubing to firm up the connection. This works similarly to solder sleeves, but the soldering of the joint must be done first.